what should I do? One thing you have understood, that is we have to, of course, but why the taking logarithm ln? Why this is required? Because in that locus we want z2 in terms of z1, but there should not be any explicit t dependence. That means we want z2, that is some constant, that will be the constant will depend upon z1 0 as well as z2 zeros, and there will be something z1 to the power something. Okay, so that is we are expecting. There should not be any explicit t dependence, but here we have explicit t dependence, so we have to remove the t term. How could we remove the t term? Then first of all we have to bring that lambda 1 t outside, right? So if you take that ln both sides, then what will happen? Is it fine? That is, if I find.
Sir, I didn't use log.
Huh?
I didn't use logs.
Any one of them. That is not because what I am just planning at this moment, that is z2 equals to, anyway, because z2 why I am starting from this one, because that is I have a what I plan, that is z2 in terms of z1. So here what I am about to write, z2 equals to e to the power lambda 2t and then z2 0. Now this t has to be replaced by this expression if I am not wrong. Then e to the power lambda 2. So directly I can write lambda 2 by lambda 1 because it is 1 by lambda 1, and then ln z1 by z1 comma 0. Then here again the same situation, that is we have to I have to take logarithm, no way. All of you please check whether I am making any mistake. Up to this much it is fine. Then what we can do?
ln is 1. So
Exactly. So after this, that is like ln something equals to lambda 2 by lambda 1, then we have to
z2 equal to the power. Yes, sir.
up to this much. Is it fine?
So we can write
power कर देंगे. So a into ln b power.
Right. That is also yes. You are right. So you were saying that is here ln z2 comma 0. That is ln. Yes. Right. After that,
z2 equal to z1 to the power lambda by lambda 2 by lambda 1.
so that means this one equals to
This power is z.
after that we have to take anti-log, right? So then that is z2 by this one equals to
z1 by z1 0 to the power.
to write it, Z2 that is equals to Z20 divided by Z10 to the power lambda 2 by lambda 1. This as a whole will be the constant which we will denote by C, and then Z1 to the power lambda 2 by lambda 1. This is the thing which I wanted. Now you see. So this is like Z2 equals to C, that is a constant term which is C means it is coming from the initial condition. So for a given initial condition it is constant, and then Z1 to the power lambda 2 by lambda 1. That is the expression. I'll have to draw the pattern. We will try to learn it in an easy way. Isn't it?
Desmos.
Right? Like through some numerical examples, we will try to find out the shape. Suppose if this is the first case, lambda 1 minus 1, lambda 2 minus 2, then what will be the equation of the locus? Z2 equals to Z1 square. It is simply a parabola like y equals to x square. So how will that locus look like? Suppose if this is the second case, lambda 1 minus 1 and lambda 2 minus 3, it would be Z2 equals to Z1 cube. Like it is another type of cubic relationship, y equals to x cube. Then we can draw it, suppose, sorry, this one. So first one is for Z2 equals to Z2. All of you please look at the board. This one they drawn with the orange color chalk. The first one is Z2 equals to Z1 square, like initial condition Z0. For simplicity, I have considered 1, 1. Although you can say that is originally x0, x1, because it is not that x1 0 equals to z1 0 and x2 0 equals z2 0. But here, for simplicity, I have considered what is my c, that is j2 0 divided by this one, right? So, and then whatever may be the transformation from the original coordinate system to this one, I am considering as if j2 0 is 1, z1 0 is 1. So that's what I have mentioned. Okay. So this one is j2 equals to z1 square. Then this one j2 equals to z1 cube. This one j2 equals to z1 to the power 4. It will be like that.
So then it will be z1 z2 plane. Z1 z2 plane.
Huh. Very simple. Z2, this is Z1. Exactly. This is whatever we are drawing at this moment with respect to the transform axis. Okay. Later we will show that this can be translated back to the original coordinate.
So but eigenvalues will remain same.
Mhm.
Even after diagonalization, the eigenvalues of the system will remain same.
Huh.
So if even which is z instead of z2 and z1, it is x1 x2, the graph will remain same.
No, the pattern, like when the shape will be changed, right? Because it will be a non-linear coordinate transformation. Sorry, it will be a non-singular coordinate transformation. Like it is what you are saying that would have been the case if this P is diagonal, but P is not diagonal, right? So from the Z1, Z2 plane, when it will be translated back to X1, X2 plane, then as a whole it will be cramped to some extent. Huh? Not only is rotation, there will be something squeezing or expanding that will happen. So, are you getting? That is the pattern is like, if this is the initial condition 1 1, and then this is now the system motion is approaching here, approaching to the here my origin 0 0. That is the equilibrium point, and you see my system motion of this like phase trajectory. This is approaching the origin. Now, as that like the ratio lambda 2 by lambda 1 as it increases, that means it as much as lambda 2, as much as like lambda 2, then it is more inclined towards this axis. Can you follow that? Because then what will happen, that is, I will draw it, first you try to analyze. Now, if the same thing, that is, suppose if the initial condition is here, from that also, that is, it will be something like, this is the first one, like y equals to x square parabola, then it would be something like this, something like this. Similarly, if it is there, then also all of the motion will be always directed towards the equilibrium point. Now there you have a doubt. That is, we have only this expression available to us. From that, who guarantees that the motion will be this side only? That you have to understand, right? Please think about that. That is, at this moment, up to this much, we have understood only about the shape. That it would be either a parabola or a cubic or a, like the fourth order relationship, something like that. Now, that is, who guarantees, or how would you like find out the motion? That means one is there, that is, if you go for a numerical simulation, then from the values you will understand. But theoretically, I mean analytically, how would you find whether it is going down or going up? Because a parabola, the motion can be outward, the motion can be inward as well. How would you find?
Stable, then it will go inward.
अरे stable अगर already है तब इसका तो जरूरत ही नहीं है. हम लोग को stability find करना है. That is, if you already assume that this is stable, then what is the point of all this exercise?
So Z1 and Z2 को greater than less than करके हम लोग देखेंगे.
So need to be about
coordinates को
So
देख
direction fields.
That means direction field is also that if you are planning to draw it on a graph, you need the numerical data.
We will be checking at the coordinates. Z1, Z2 का माने first coordinate, second coordinate, third coordinate, fourth coordinate में कैसे हो रहा है?
At this moment, suppose this is Z0, this is my simply that is 1, 1. So that is what will be the, in which direction it will move. How would you find that? Without calculating. This is completely, that is like many times I said, this is a qualitative analysis.
How Z2 is behaving with respect to Z1 if it is in positive coordinate?
You have this relation Z2 equals to some constant into Z1 to the power this. Here we don't have any explicit time dependence, right? Now how would you decide? That is, for a locus, if you draw it on a pen and paper, then you definitely need the numerical values. But what I said, we don't need. At this moment we are not planning to draw it on the graph. So we are drawing it completely from our understanding. So how would you analyze, that is, here the motion will be in this side or this side?
So it will depend on the constants.
Here we don't have any constant. Here only the nature of the eigenvalues.
From lambda 1, lambda 2.
I get it is negative.
Then lambda 1, lambda 2, both of them are stable eigenvalues.
Then that will, so if it is stable, it will come inwards. Otherwise go outwards.
So then how would you like find out the shape? See, from this, that is only from this relation, you know the what you were thinking, that is not at all the reason. You both, you and Faiz, you both were thinking about drawing the thing or from the numerical values. No, here completely we are trying to find the qualitative things. We don't have any values. Okay, you have mathematically, you have to find out, that is what will be the trend, that is what will be the motion. See, here when you have Z2 equals to some constant into Z1, you don't have any time dependent term. Only from that equation you cannot decide whether it is coming down or whether it will go up. From that, for that you have to come back to the original equation. My Z1 is the independent variable, so Z1 equals t to the power lambda 1 t Z1 0, right? At this moment what we consider, that this is a stable eigenvalue, because this analysis is for stable eigenvalues, distinct eigenvalues, sorry, both of them are negative eigenvalues and distinct. So Z1t, it will be decaying. So if you individually draw the response t versus Z1, then it would be like that, e to the power minus t. And then that is here I considered Z1 0 to the 1, so it would be e to the power minus t. So the value of Z1 will be exponentially decaying, okay? Now you think about that. Suppose the C is now equals to 1, what I have considered. Then here, what is actually happening? E to the power minus t. Now at each individual time, whatever may be those numerical values to the power 2. That is the reason why now, that is following the relationship will be the parabola only. But what will be the system motion? Starting from this, it will come down, not go up. Are you understanding? First of all, that is Z2, all these relationship like Z2 equals to Z1 square or cube or 4. We first try to understand what will be the shape. Now once you get the shape, that is not the end. After you get the shape of the locus, then you will have to find out the motion. That means starting from here, I drew it. So at this moment you can say that, sir, already you have drawn. But how did I draw? That is the question. You have the initial point fine, but from that, whether it will go this side or this side, how do you? Because parabola can be, that is anywhere. It can even happen that is from there it will go down like this. But you have to understand that is what is the pattern of the independent variable. Like here, what is the x-axis? My Z1, and then how you are getting the Z1 values. For that, you have to go back to the original equation. So Z1 value, it starts from plus 1, right? At t equals to 0, it is plus 1, and then it is exponentially decaying for all of these values to the power lambda 2 by lambda 1. So that is the reason, that is why it will follow the parabolic relationship, but the values will continuously fall, not they will grow up. Are you getting? That is the reason. Try to understand. Now that is for whatever may be the location of the initial point, everywhere the pattern will same. And if you see, that is depending upon the relationship, it will always come back to the origin. It is called a stable node. This is one of the face plate, I mean like this kind of equilibrium point is called stable node. So when the A matrix, or in case of linearized, if the J matrix contains two distinct negative eigenvalues, then the corresponding stability property is stable node.
So can you please repeat the concept?
First of all, like you see, if I don't have the picture, suppose I haven't drawn the picture. Z2, Z1, you have the initial condition here, Z0. Now the case is that you have to draw the locus, I mean the phase trajectory. You have to see the equation of the locus. That is my equation of the locus. Z2 equals to C into Z1 to the power lambda 2 by lambda 1. Suppose let us start with this case, where lambda 2 is twice that of lambda, I mean value wise, magnitude wise, lambda 2 is twice that of lambda 1. So lambda 2 by lambda 1 is 2. So Z1 square. You can take any of the relationship like Q, 4 or 5. Then you have a pattern in your mind. That means when you draw a parabola, like this is a parabola, but whether the system motion is going this way, Nitisha, please look at the board. This is the drawing of a parabola, but here what is really important, whether the system motion is going like this or it is coming down. Because if it goes like this, then it will be an unstable node, an unstable system. But if it comes down, then it would be a stable node. So that's why not only the pattern, I mean not only the shape of the locus, the motion is really important, the direction. So how would you find the direction? That is whether the system motion will come down or will grow up. So then this is your Z1 axis, this is your Z2 axis. You will have to first find out, that is what is the pattern of Z1, whether Z1 values increases from Z1 0. I mean starting from the initial condition, no external input is there. Starting from Z1 0, whether the values of Z1, that variable, goes down or it goes up. If it goes down, so then definitely what will happen, that is this Z1 to the power lambda 2 by lambda 1, that will also reduce, that means that will also decay. If Z1 decays and now Z1 is a positive, that is also a case, that is in this case Z1 is positive, right, because Z1 0, if that is my positive, they have said Z1t, all of them, that is positive. So in that case, if some positive value goes down, then its power will also go down, and that to power greater than 1. That is the reason, that is why Z1 is continuously decaying, and accordingly Z2 will also decay. But the rate matters. Rate matters in the sense that is here, this pattern is like, I am considering all of them like y equals to x square, x cube, x4, x5. Now you think about other way around. Y equals to x to the power half, 1/3, 1/4, 1/5. Then what will happen? Exactly the other way around. But then also the direction will be downward. So that is if we just, the situation is reversed. Suppose the magnitude of lambda 1 is like twice, thrice or 4 times of lambda 2, then the relationship would be Z2 equals to C into Z1 to the power half, 1/3, 1/4, 1/5, like that. So what did we learn? First of all, you have to find out the pattern or the shape of the loci, and then you will have to find out the direction, I mean the motion, whether the value is increasing or decreasing. Because if it comes to that equilibrium point every time, please remember that if it goes towards the equilibrium point, then it is stable, or if it diverges from the equilibrium point, then it is unstable. So if it converges, then in that case it is called stable node. Otherwise, earlier case, unstable node. Are you getting? If you see the book, you will find that is they will draw a family of like this kind of relationship. This is the diagram you will find in the book. You can ask that is why you were drawing that is so many corresponding to different lambda 2 by lambda 1. Okay. Different lambda 2 by lambda 1 and of course with respect to different initial conditions. Can anybody tell me that is how did I draw these perfectly straight lines when they will appear? When one of the initial condition is 0. Please check that whether you are confident about that Z10 and Z20 like the initial condition is like if it is 0 comma plus 1 0 comma plus minus 1 and also plus minus 1 comma 0 or even you can think about 0 comma plus minus c and plus minus c comma 0.
Sir, Z20 is in the denominator. If it is 0 then the system.
Z10 is in the denominator, right?
Yes.
Oh, actually here that is what happens because with respect to the original ones, that is x1, x10, x20, yes, that is x10, x20, there if we consider 10 or 01, then after like z0 that means p into x0. So there it is getting some non-zero component. So that is at this point since today it is like quite late, so I am not going down further. That is, we have understood the basic pattern, that is like stable node and unstable node. Stable node means for whatever may be the initial condition, they will be attracted towards the origin. Here I am assuming the origin is the equilibrium point. So all the from wherever you start, the system motion would be directed towards the equilibrium point. Okay, that means converging trajectory. Okay, so that is called stable node. If the direction is opposite, that means the same thing. You just use the positive sign here. If lambda 1 plus 1 and lambda 2 plus 2. So then what will happen? Z1 will be e to the power plus t. Z0, right? Are you getting what I am saying? For unstable node, my Z2 is still the same, C into Z1 to the power lambda 2 by lambda 1, right? Let lambda 1 equals to plus 1 and lambda 2 equals to plus 2. The relationship will remain the same provided, and suppose I am also considering c equals to 1, then that will give you z2 equals to z1 square. The same shape will be there, right? Now you think about that what will be the values of z1. So now that is what is the solution? z1t, that is z e to the power lambda 1t, right? So this will be to the power plus t into 1 because z10 is my 1. So that is e to the power t for all t greater than 0. So if you draw it, then suppose this is my 1 and this is my z1, this is the time trajectory tree, exponentially growing signal. Now what happens? That is from like starting from one initial condition, it will go above. That is, suppose if you start from here, the system motion will be like this. Never it will come down. Because then why? Because then what will happen? Z1 value is increasing. That means it's square. Especially when the power is greater than 1, then it will go up, right? That is the difference. All of you, that today I am stopping here, but you take a few moments more to understand the situation. It is completely analysis of second order systems. Here we haven't yet applied any difficult mathematical tools. Everything, whatever we have studied up to our class 2 level, only those simple mathematical techniques we are applying. But the thinking is quite deep. If you have any doubt, please feel free to ask. Kashif, any problem? Ashutosh? So we have learned stable node and unstable node. From next day onwards, that is, we have to learn the other cases. I give you, there is only the small task, that is, if this is the derivation, then what will be the cases when lambda 1 equals to, suppose, if your lambda 1 equals to lambda 2 equals to lambda less than 0. So please find out what will be that case, okay? And then the second one, that is, suppose lambda 1 less than 0, lambda 2 equals to 0. 3, lambda 1 equals to 0, lambda 2 less than 0. Just you try to find these three cases, okay? The main derivation we have learned. Now, if these are the three sub cases, then what should be their loci? So first of all, both repeat negative eigenvalue but repeated. Second one of them negative, other one 0.
আমাদের যেটা ধারণা রয়েছে ইন্ডিয়ান এই জায়গাগুলো অনেকটাই ইজিলি শেয়ার করবো
করতে পারো। ধারণাটা এসএন ধারণা, তাই না?
ফিজিক্সটা ভুলে গেছে, বাট ইন্ডিয়ান অথবা খুব ইজি এগুলো।
Mukesh, is it fine? Ashina? What? हाँ। उन्हीं का कैसे चल रहा है?